First and foremost, as I did say on Friday, I would like us to finalise question 4a. As you can see, we've got a 6 by 6 by 6 cube, and actually a 4 by 4 by 6 prism has been extracted from it. So in order to work out the total surface area of this prism, let us break it down into different 2D shapes. So to begin, we've got 1, 2, 3, that's at the bottom, and 4, that's at the side. 6 by 6 squares. And then we've got 2, 6 by 6, take away the area of a 4 by 4 square shapes. So we've got one at the front and one at the back. And finally, yes, you were correct, inside we've got 4 by 6 rectangles. So one at the bottom, one at top, one on this side, and one on the other side. So to work out the total surface area, we have 4 times 6 by 6 plus 2 times 6 by 6 take away 4 by 4 plus 4 times 4 by 6. So if we were to simplify this, we would get 144 plus 40 plus 96, which gives 280 centimeters square. Please remember that it's units square because we are working with area. Now, looking back at Friday, we moved on to a new topic of compound measures. Now, compound measures is all about showing how one quantity changes in relation to another quantity. For example, the speed of a car, that's kilometers per hour, or how quickly liquid can be poured from a container, that's liters per second, or something known as density, that's mass per volume, in this example, grams per centimeters cubed. Now, another way of looking at compound measures is to think about it as a measure of rate of change. Now, in terms of the grade, it goes between C to B grade, but at times it does touch A grade. I'd like to go over 2 examples with you. The first example, some of you will be familiar with, but I would like to go over it for everyone. So a car travels 260 kilometers and uses 20 liters of petrol. For part A, you've got to work out the average rate of petrol use, and you've got to give your answer in kilometers per liter. So simply, we take 260 kilometers and divide it by 20 to give us 13 kilometers per liter. Now for part B, it says estimate the amount of petrol that would be used when the car has travelled 78 kilometers. So to work out the amount of petrol, we take 78 kilometers and we divide it by 13, which should give us 6 liters of petrol. Now, example 2 deals with speed. In general, the average speed is total distance travelled divided by total time taken. Now, in this example, they're telling us a horse runs 12 kilometers at an average speed of 10 kilometers per hour. How long in minutes and hours does this take? So let us first of all look at the formula for speed, which is distance over time. This actually implies that time is therefore distance over speed. So we can now begin by substituting the relevant values for distance and speed. So time becomes 12 divided by 10, which is 1.2. Now this 1.2 actually represents decimal hours, and we're interested in hours and minutes. So we can look at 1.2 as 1 plus 0.2. That's 1 hour and 0.2 of an hour. We then need to change this to minutes. So we have 1 hour and 0.2 times 60 to change it to minutes, which gives us finally 1 hour and 12 minutes. Please make sure that you do copy down the title, the date, the learning objectives, and I do encourage you to take down the examples, which will be very useful. The actual textbook itself has all the relevant formula that you will need for this exercise, which you are to complete the following. From page 25 and the following exercises. So all the very best for today. After you've finished, you can check your work. The answers will be displayed. And here they are.